Hello everyone. Today let's talk about a brief introduction to multiple decrement models. So first, what is a multiple decrement model? It is the special case of a multiple state model, and it only has one active state and multiple exits, which we call the decrement states. And exit states are absorbing, which means once you leave the active states, the process stops and you can never leave the exit states. And it's very useful for modeling competing risks such as death versus disability versus withdrawal. Let's see some examples here. We see here, this two is to multiple state model, which is like alive can be state in alive or healthy, which we call here is state 0, and it may be disabled into state 1, which we have here a transition from state 0 to state 1, and people can be die at both times, so they can always be transacted to state 2, which is dead. And also we can have like a healthy states 0, and people may get sick when they like go to state 1, and then they can also get back to state 0 when they recovery, and also in both states they may be dead, or they can go to the state 2. Meanwhile, today our example about the multiple decrement model is like here. We only have one active state, states 0, and we have different exit states, which is like a one-way arrow. We just go in and we can never leave here. And we have our different mu01x here as the force of transition. They have every decrement states, we have a specific force of transition, like what we have here. And this is a very typical multiple decrement model, which when the policy is in force, it stays in state 0. And then when people dead, we go to the state 1, and when maybe if the policy is terminated, we go to lapsed state 2. And also they have their own force of transition, mu x01 and mu x02. Okay, so this is briefly what we have to be know about the multiple decrement model, like what we have here, right? And let's now introduce three very useful formulas. The first one is the probability of staying active, which is the probability of staying in these states, and we have to calculate it because maybe like most time if we in these states, we will have the premiums, which is very good for us. So we need to calculate about it for the future calculations of EPV or something else. So we have here the probability the life remains in active states until time t is this formula. Why should we have this formula here? Because just don't forget the MDM is a special case of MSM, and in MSM the exponential survival form of a TPII bar is the exponential of minus integration of all the force of transitions. So here we just simply get all the force of transitions from ij to 0j here, which we can see in the multiple state model we have like very different transitions here, but here in the multiple decrement model we only have active states to exit different exits, so all the mu is from mu 01, 02 and 03. So like we have the summation of j from 1 to n, 0j, and we can also use another notation here, the 0 dot, which means all the j is included here. And this is our probability of staying active. Then we come to the probability of decrement j, which means we have to calculate the probabilities from active to exit 1. And this is very, very important, since this is the main part of what we want to calculate in the EPV, which let's see here is like this formula. Tpx0j equals to integration rpx00 mu 0j x plus r and with 1 dr. So why it is in this form? You may be very confused, but let's see about this chart. We want to have the probability of leaving the decrement j in 0 to t. So what happened in 0 to t exactly? We can see here. First, we stay in the active state rpx0 for time r, and then in a very short period of time, using the principles in the calculus, we can see here we use a very short period of time of dr, and we have the probabilities of transition using the force of transition to multiple the time dr. So this is the probability when we go from 0 to j, and then we stay in the exit state of j, which, since you can see here, we can't leave the exit, so the probability of staying here is always be 1, which can be omitted here, but we just added here for clearance. So the main part is here. We use let me just repeat it again. From using a very short time period dr, and by the force of transaction, we multiply them together, then we have the probability of transaction from 0 to j. Okay, so this is the second probability of decrement. Then we have our last formula, total probability of leaving active. Here we define 0 tpx0 dot, means it is the summation of all the probability which we leave here. Like we added the probability of leaving from here to here, here to here, here to here, here to here. Like we added all this probability from together from 0 to j together. And we have two calculation method here. The first one is probability the life has left the active state by time j, which we have already calculated tpx00 here. So it's just merely 1 minus this part. And the second way is we can also be written as a sum of all decrement probabilities. Like we have the ability to calculate each one of them. So why don't we just add them together? So this is basically two ways for us to calculate the total probability of leaving active. Okay, we have finished all our formulas here today. So let's see a brief example. Suppose we have an active state with two decrements, death and withdrawals, which we just notation as lapsed here, which means we have three states, 0, 1, 2, and only 0 can go to 1, 0 can go to 2, we cannot have any other errors. Then the survival probability we can see here is tpx0 is the exponential of the summation of the two force of transitions, which is perfectly have let's say here, right? We just added them together, and which means we added the two force of transitions here, and we just simply have the answer. And for different like tpx0102, we have their probabilities, then multiply with the force of transitions, and just simply integrate it like what we did here. So this is basically how we get these formulas. Okay, we have been done with all the parts today. So let's give us a brief summary. First, MDMs are special MSMs with only one active state and multiple absorbing states. And second is the decrement-specific force of transitions, mu0jt, drives the transactions probabilities, which we can see here in the three formulas, which we all have to have the part of the force of transitions, which is very important here. And this is the three formulas. The first is calculating the survival probability with all the force of transitions added together and put them just above a E. And we have also the probabilities of leaving via the decrement which we have here, and the very, very important principle here. And the third, the probability the life has left the active states by time t, which is the total probability. And these are very useful in research benefits with multiple termination causes, like this one, death and lapse. So this is the main part we are going to talk about today. Class is dismissed. Have a good day.